Hello everyone. In this lecture, we will learn about coincidence constraint tool. Constraints are very important features to limit the degrees of freedom in order to determine the relationship of one component with another component. Any unconstrained part in 3D space is said to have 6 degrees of freedom. That is 3 translational movements along x, y and z axis and 3 rotational movements about x, y and z axis. Normally, the toolbar which contains this coincidence constraint tool is hidden under the other toolbars. Let's drag and move other toolbars. We can find the coincidence constraint tool on the constraints toolbar here. This tool creates coincidence between two selected points, lines or axes or two planes or two surfaces. Let's understand this through an example. In this example, we want the circular shaft component and the hole on the rectangular part to be coincident. Double click on the main product. Click on the coincidence constraint tool. An assistant dialog box opens up saying that this function works only with active component. Currently we have activated the main product. Click close. We can read the message bar for help text. It displays information like select the first geometric element of the coincidence constraint, which can be a point, a line or a plane. Point the mouse over the cylindrical surface of the circular shaft. CATIA automatically deducts its axis. Now we need to select the second geometric element of the coincidence constraint. Point the mouse over the cylindrical surface of the hole. We can see that coincidence constraint is created. We can identify this through O symbol and from the specification tree. Click on the update tool. We can see that product is updated with the coincidence constraint. But we want the direction to be reversed in order to fit into the hole. Let's undo the process. Click coincidence constraint tool again. Now select the surfaces like this. We can see that an arrow is displayed on both the parts indicating the orientations. On the Constraints Properties dialog box, select the orientation as opposite or click on the arrow to reverse the direction. We can see that product is updated with the coincidence constraint. Now click coincidence constraint tool again. Now select the axis of shaft and hole. Now let's check the degrees of freedom on the components. Double click on the product. Select the circular shaft and right click. Select circular shaft object and select component degrees of freedom. Degrees of freedom window opens up saying this component has 6 degrees of freedom. So far, using coincidence constraint, we have defined spatial relation between these two components. But we must think carefully if this part is designed with any degrees of freedom once it is assembled together. If not, we can apply fixed constraint to fix this component to arrest 6 degrees of freedom. Click on Fix Constraint tool and select the circular shaft.